A very warm good morning to everyone present here. I hope you all are doing well. With immense gratitude, I welcome you all to the second day of our national conference on the use of smart contracts in public procurement and supply chain. I would like to thank all the eminent speakers, dignitaries, and all the audience members for joining us today. So let's start our session. For the very first lecture will be given by Shri Deepak Lalan. Shri Deepak Lalan is Associate Director at Accenture, Bangalore, India. He served as the blockchain practice lead for Accenture Technology in India. He holds a master's degree in business administration from the University of Wales, specializing in international business. He has been associated with various projects like the SBI In Touch, SBI Buddy, Accenture Innovation Hub, Geological Survey of India, Online Core Business Integrated System, and the world's largest biometric-enabled national identification system, Aadhaar. So I request you, sir, to please come on the stage and address the audience.
Hey, good morning. It's good to see few of you have already come. So thanks a lot and good morning. And I really appreciate Madhu sir and Dr. Acharya to give this opportunity and Shuklaji to give the opportunity to come and speak here. What we will do today is we are going to speak about, yesterday we spoke about what the smart contracts are, how is it working with blockchain and so on. So today what we will do is we'll understand what the limitations are if you go and implement this, and what are the challenges and what the future of blockchain might look like. And my colleague Swati will also continue and talk to you about what the future of smart contracts might be. So I will not step into it and let her also cover a few things. So what we will do today is we will talk about the overview. We will do the implementation challenges, limitations, intangibles of what blockchain is, and then we will see what the benefits are. Is this better? Okay. Let me take it off. Okay. Let me go back here. Yesterday we had a question. How does blockchain get implemented? Where does it get implemented? Smart contracts, where does it get implemented? How does it get implemented? So I thought I'll give you a small analogy so that you can appreciate what the implementation challenges are and what the limitations are, right? So let's think of a website. If you think of a website, what do? You write a HTML code and a JavaScript code, right, on how the website should look like. Think of that as a smart contract. Now, you can't access the page until and unless you put it on a server, right? Or if you make a copy of it, you can just click on your laptop and it opens up a page on a browser. So now the smart contract or a web page needs to be deployed on a server. In this case, it can't be any other server for web pages. It has to be a web server so that it understands the HTML language and it has to understand the JavaScript and so on. So you need a web server for it. Similarly, for a smart contract, after you've written a contract, it needs to be deployed somewhere. Now you have a choice whether you put it on a blockchain, and now you have a choice of what type of blockchain, right? It can be a private blockchain, it can be a public blockchain. Within that you have Ethereum, you have Polygon, you have Fabric and so on. So the choices are many. Now once you've deployed it, now you need to invoke it. You have to call for it and then it can then get executed. Similar to a web page. If I have to do that, then I have to open up a URL. So I'll have to give www.accenture.com or something like that, or amazon.com, and then it invokes the code which you have written for it to then show that page on your browser. So similarly, your smart contract, when you have enabled it and you put onto the server and you put onto the platform, whichever you have chosen, now it needs to be invoked. And there are multiple ways to invoke it, and once it is invoked, you could do it from your web app, and then it calls the right smart contract. It could be a web page. The applications and the use cases which you see might be multiple of those, yeah? Okay. Sorry for that echo. I'm static, I guess. So that is how, now if you can relate it, now you know it's just not a magical thing that I talk about smart contracts and it gets deployed somewhere and you don't know where it is getting deployed and it magically gets invoked and run. So you can equate it and have an analogy of a web page and then understand this, right? Now with that mental picture, we can talk about what are the implementation challenges, what are the smart contract limitations, and what are the intangibles which we can look at, and what are the benefits you can get out of it. So with that, what we will do today is very quickly talk about me, where do I come from and what do I do, and then we'll jump into it. So I have spent about 22 years in the IT industry, done some amazing disruptive projects like Aadhaar. So I was the chief architect in Aadhaar, working with Nandan, Nilkani and others to put the Aadhaar into the world map. Done some work with GSI where the Gagan satellite for our GPS was put in by our ISRO, and we said, okay, we will use our own GPS satellite than using the Galileos of America or Baidu of China. So things like that. I've been nominated or recognized as the top 30 blockchain influencers in India, and been doing some TEDx and other keynote stuff. My passion, technology. I've always been in technology, in emerging technology all over. Family, of course, everyone loves their family, and family comes first. And I'm an adventure junkie. So no other bad habits other than putting my life in danger. So I do skydives, I go into scuba diving, I do kite surfing and so on, so I can bruise myself everywhere when I go back home. And people think that my wife has beaten me up. So it's not the case, it's just that I've done all my adventure stuff there, right? Specialization, very quickly. Of course, blockchain, DLT, metaverse comes up there because I've been doing it in the past 6 years or so. I'm a multi-cloud architect. You need to deploy all of these, so you need to know what clouds are. Biometrics because of Aadhaar, doing it for US visit, EU Commission, and so on. Strategic planning and execution, enterprise architecture, and the coolest stuff is the innovation ninja. I didn't find any other name for innovation there, so I added ninja there. So I might be as sneaky as possible in the innovation space. With that, everyone loves their phone, right? So I'm not talking about this phone, which is the rotary ones which we had, but this phone. So everyone has it, so if you have it, please pick it up. Usually everyone in their college or they're in lectures say, keep your phone away. But what we will do is I'll encourage you to put your phone, bring your phone up, and we'll do one thing. You can go into menti.com and then type in the number there. Or if you can scan the QR code, I don't know if you can scan it from so far, it would be great. So go to menti.com, open your browser, and type in 48 96 86 43. So once you're ready, you will see a thumbs up or a heart there, so keep clicking it. So I'll see how many of you are here. Sorry. Yeah, there is a thumbs up at the bottom, so you just click it and be ready for it. I'll take you through the next slide. Cool. I see some participation, so I love it. So menti.com on your browser, and then the code is 48 96 86 43, or you can scan the QR code. Yeah. So I have about 40 of them. How about we get 50? I don't know if we have 50. If you have two phones, use those two phones. We can reach 50. How about that? Yeah, Cool. So we have 46. I'll move on and then if you guys are there, okay. I think, yeah, one more and we'll be at 50. I'll have to use my own thing, okay. We have 49 then. Thanks a lot for that. What we will do is, and again, I'm not a tickler for seriousness. Have you guys seen this movie, the English movie called Pacific Rim? No? Has anyone seen it? No? You can say yes, no, or you don't at all watch English movies. So, I say yes, about 4 of them, no, a lot. Don't watch English movies. With RRR winning his academy this year, I guess you can boycott English movies. Yeah. So cool. So the Pacific Rim is a movie where you have a very big giant robo which has about 10,000 tons in its weight. Yeah. And to operate it, they didn't have artificial intelligence in the movie, so you had to operate it manually. So when you had to operate it, because it was so heavy, you needed 2 pilots to operate it, right? And the way it used to operate, and you operate that is, you had one person operating the left side of the robo and one the right side, and they had to sync their brains to operate it, right? And I want to do this exercise with you so that I get 100% of your attention with me, so that I sync your left brain and right brain. It's a very simple exercise, takes 2 minutes so that we energize this room. I can't see serious faces. I know you guys all come from either the Navy or you come from the financial background. So let's do this exercise. So when I say head, you touch your head. Yeah. So head. Cool. When I say clap, clap. Cool. A louder clap. Cool. And when I say stomp, stomp. Cool. So let's do this one quick time. Stomp, clap, head. So your left brain is activated now. Let's activate your right brain. When I say clap, you stomp. When I say stomp, you touch your head. When I say head, you clap. Yeah? You do a cyclic. You get that? Stomp, yeah, stomp, yeah, clap, and then, yeah, clap, head, and then head, stomp. Cool? So let's do this the easy way. Stomp, we'll stomp. The easy way is no thing. Stomp, okay, clap, head. Cool, I see smiling faces. Now let's make it complicated. Stomp, cool, head, stomp, clap. Cool. So we have now synced your left and right brain, and I have your 100% with it. So thanks a lot for it. Sorry, my clicker is not working. I just wanted to ask you, when I talk about smart contract, right? And you heard about it and you learned about smart contract yesterday. So yeah, I need to. I'll take a. Okay, I'll figure this out. Yeah, I'll take a mic. So yesterday you went through smart contract and everyone gave you an example of it and you learned about it. So can you think of any smart contracts which is an example from your real life? If you do, then type it in on your mobiles and let's see if you have something. Yesterday we had an example of vending machine. Don't put vending machine. Professor had put vending machine. So do you think, is there anything like a smart contract in our real lives which we use on a day-to-day basis? So we have few answers. Okay, ATMs, that's a nice answer. UPI transaction, that's a nice answer. Land registry, okay, it's too far, then too many parties need to come, but yeah, you could put that there. Cool. So, fare collection, yeah, the FASTag, you pay and you can go through and use it, so something like that. Cool, so some good answers there. CBDC is still not in our real life yet. POC is only but it's a great answer. So ATMs and, okay, prenups. In India, prenups are not legal, so that's okay, but somewhere very close. Um, Insurance and so on. So I think with this, I know that you guys understand what a smart contract is and what it lays down. So now I can talk about what limitations are and where do we go from here, right? So that's great stuff. So vending machine is the grandfather of all smart contracts. ATM is their newer version of it and so on. So thanks a lot for engaging with me there. So very quick recap. What makes a smart contract smart, or why is a smart contract a smart contract? Uh, One of the most basic thing is that it needs to be deterministic. And we were talking about it yesterday. What happens if it is an ambiguous or a very subjective implementation? Then it can't be a smart contract, right? It has to give you an answer. It has to be yes, no. It can't be a maybe. So when it goes to a maybe, then you can't execute it. It goes into an exception, and you don't want exceptions. So you put a smart contract where you know 99% of the time it will give you a deterministic answer. Maybe because we do in procurement and supply chain, there will be ambiguity, and there will be some cases where you don't know what the answer is. That can go into an exception, and you could write a smart contract saying that if there is something which you can't determine what it is, then you can say we'll execute a exception where we talked about oracles being human oracles being the doing the audits or looking at it and then taking care of it. Yeah. So it has to be deterministic. It has to be a code written to make it deterministic. Then it has to be autonomous so that you don't need any manual interventions or your governance. So it has to run by itself based on what you have written. And the last thing is it needs to be trustless. So why it needs to be trustless is once you've given the code and you ask it to run somewhere, it has to run without any issues or you saying you have a doubt that it will be executed the way I've written it, right? And hence it enables trustless. So for example, your legal contracts which are there, you trust it because any law, you take it to any court in India, it will be valid, right? Because you trust it. It need not be that I've written it in, or I've done this in Bangalore and now I'm in Delhi and I don't know if the Delhi court is going to work on it and then say it is fine or not. You are not worried about it. You know you can bring it here and then work it out. All you do is in the clause say that the jurisdiction is within the premises you want because you don't want to travel because the going to the court and coming back is a long process, right? 10 years, 12 years, you keep going to the court. So that is why you need these smart contracts to be all these three to make it not smart as in artificial intelligence, smart as in that you can trust it and it can execute the way you want it. Cool. So I guess this works now. What is the current state of smart contracts then? It is very experimental, right? So everyone are trying to use it in different use cases and use it in different ways to see how we can implement smart contracts. And then the newer languages are being used, newer ways of implementing it. Then you're looking at privacy and how do I make sure that the privacy doesn't get violated. So there are a lot of experiments going on. People are working on it. Like yesterday, one of the speakers were speaking and he was working on the layer 1 where the smart contracts get deployed. You can do parallelism once it's deployed and then you can have more privacy which his colleague was doing and so on, right? So all of these are very important and the current state is that we are working on it and we continue to improve, right? And you saw that it just started in 1996 when Nicholas actually first coined the smart contract, and now with Bitcoin it became much more popular, and with Ethereum it's now a little more forward, moved ahead. But we still have a lot more to do, but it is changing and a rapid implementation and experimentation is happening in this space. With that, I want to, again, don't keep your phones away. I love your phones. So what we are saying is there is DAOs and there is decentralized autonomous organizations which are there, right? And they run on smart contracts. The main important use case with smart contract getting implemented in the future, according to me, is DAOs. You don't need people. You don't need a CEO to run certain things. You don't need politicians. You don't need a prime minister. You don't need a government. Yeah, I'm going too far, but no one can stop me because I'm here. But all of those are very important because we want it to become as autonomous as possible, right? And smart contracts are the base foundation to it, right? And do you then say, will DAOs become the future of organizations and governments and countries? So I have few of them saying yes, no, and few of them don't know what is DAO. So we'll just tell you what DAO is because I've got majority of them, or 12 of them who don't know what DAO is. So the full form of DAO is decentralized autonomous organization. That means that the entire organization is run on a code. So there is no person, there is nothing. It's purely coded, and you're given the ability to vote and say, okay, I want to vote for this policy, I don't want this policy, I want to invest on it, I don't want to invest on it, I want to hire Deepak Lalan, I don't want to hire Deepak Lalan. All of those are given to a general people who are there, who have the token, who have the ability to vote, and they can vote and say yes or no, right? So in a traditional organization, what happens is you, or in a government, you vote one person, and then that person then takes all the decisions on behalf of it for the, okay, this is bad. Okay, let me come back. I can't stay in a dais like this, so you can't see me and my hands, so I'm very animated that way. I'll take that back, yeah. Can I get the mic again? Acha, so till they get. So it is all run by code, right? That's what DAO is. And everything is a code, and you get the opportunity to then vote up and down, and then based on it, it runs. With that in mind, and that's what DAOs are, do you then think, and everyone loves Uber, right? Uber or Ola, and they have revolutionized the transport we have. Do you think today, whatever Uber is, can I kill Uber and say, okay, I don't like Uber and I want to do something else better than Uber? Can I do that? Yes, no. Yeah, who thought that we will never use Google? With ChatGPT, we are saying we don't want Google anymore. Yeah, because we get more concise answers. So this is a more redundant question. So most of them say yes. And again, going back with this concept of DAO. Now what is happening is all the control of what Uber does, what the fees is, how do I get the onboard a driver, when should I put a search price, when should I not put a search price. And if you guys have seen this wonderful series in Netflix called Super Pumped. So it's a nice Uber story there. So there, if you see, they did something called as greyballing. So there were auditors who were there, and they never let the cabs go to those auditors, and they figured it out. If this guy is coming at this pace, then they know that this guy is there. So they could hack the system to doing what they wanted to do. Now everything is under Uber's control, right? So how do I then take that off? You can take it off by implementing DAO, which runs smart contracts. Every decision which is taken is run by a smart contract. I want to onboard a driver, smart contract will onboard it based on his driving license, which you give with an oracle, which we can look at it. Or I want to increase the search price. I want to put a surge price there, or I want to remove a driver. I want to give service to a certain city or not give it. It was all based on the CEO's decision. Now you can leave it on a code to do it. And that is what DAOs will bring in future. Just imagine how powerful it will be that it is fully driven on people who are interested in it, and then you vote it, and then it does run it on your behalf autonomously. So there is already an organization or multiple of those which have now started killing, where did it go? Which has started killing Uber. This is called Drive, which is run totally on a smart contract. There's no person in it, there is no CEO in it. It's a co-op, totally run by drivers, run by users, run by a smart contract put on a blockchain. How amazing is it? Did you think this was possible? It is already doing it, and Drive has already its presence in India. And if you guys have not used it, use it. You don't pay Uber, you pay directly to the drivers and so on, right? So that's another example. Now, based on DAO, a little more insight to it, if you go a little deeper, there is DeFi, which is decentralized finance, right? And that's also becoming popular. So now your entire treasury, your entire finance department can be run on a code. Yeah, and you want to make sure there are complex things which you want to do it. We are learning. We are not there, but it is still happening. And one of the most complex and successful example of it is called Maker. Maker DAO is a DAO which equates your cryptocurrency. You deposit your crypto. It gives you a DAO token, and the DAO token is equal to $1. And now dollars, the cryptocurrency, you know, it goes up and down like crazy. I was a billionaire a couple of years back. Now I'm not even holding 20K per Bitcoin. So life is so bad. I thought I'll retire, but now I have to work a little more. So I'll just give you a good glimpse on what MakerDAO is from a much better person than me. So please hear this for 2 minutes and then we'll come back.
Is exactly what it sounds like. It's a DAO, or a decentralized autonomous organization, and its purpose is to make DAI. DAI is a digital dollar backed by locked up crypto assets like ETH, BAT, WBTC, KNC, and more. And what Maker figured out years ahead of the explosive rise of DeFi is that a stable coin could be established by incentivizing locking up more value in what was once called a CDP, or a collateralized debt position. Now today, CDPs are called vaults. But if you think about it, a stablecoin is normally backed by dollars. But in crypto, we have these hugely volatile assets. So how do you do it? Well, here's how it works. Say I own ETH, and I believe the value of ETH will continue to rise over time. Now, I don't sell ETH because I believe it's a store of value, like BTC or gold. But if I can borrow against the value of ETH in DAI, then I can have the best of both worlds. I can remain exposed to the upside of ETH long term, while spending less of that value in the short term with DAI. While I've minted or borrowed that DAI, I pay an interest rate just like you would borrowing from a bank. But it's all automated by the code in Maker. In MakerDAO, you can deposit and lock up your ETH, as well as other popular liquid crypto assets. And in exchange, you can borrow up to 66% of every dollar you deposit. And this means if you deposit $100 worth of ETH, you can borrow up to 66 DAI, but the code ensures I keep my word of maintaining that loan, or else I will be liquidated by Maker. If I don't hold up my end of the bargain, my ETH is then auctioned to others in the Maker community willing to buy it, so that Maker can remain solvent and pay back my owed debt. And the key takeaway here is MakerDAO remains one of the most successful DeFi projects built on Ethereum, with just under $200 billion in TVL, while nearly 900 million DAI have been minted to date. Unlike your fiat, DAI is digitally scarce, and it's traceable on the Ethereum blockchain. But because MakerDAO uses game theory to incentivize borrowers to lock up their valued collateral in exchange for an over-collateralized digital dollar, DAI has effectively become one of the most trusted, trustless digital forms of money. Despite the volatile markets over the last few years, including a 95% drawdown in the price of ETH from all-time highs, DAIs pegged to the US dollar held. And that's a testament to some of the best incentive design in the DeFi game. You've been watching DeFi 101. Do be sure and check out the other videos in the series and subscribe to the channel so you don't miss the new videos as they drop. And above all, stay safe out there.
So that's, and it's pretty complicated that you need to take a cryptocurrency, peg it to a dollar. If you don't, if you pull the money out, then, or if you are not able to pay it or liquidate it, then it can do it for you, and that way maintaining it and all of those. And believe it or not, all of this is run on a smart contract. And till today, from yesterday to today, the notion was that there is one smart contract and you run it. But if you'd see, the maker has so many smart contracts, each of them talking to each other, right? So it's not just one smart contract and you write that, but it is multiple smart contracts talking to each other. So another analogy for this is, so the another analogy for this in the technical realm is microservices. Today everything is run on microservices. Think of smart contracts as a microservice, and you run each of these as a service, and then you call them as and when needed. So if the maker has to work, these are the number of smart contracts it needs to run, and it needs to interact with each other, and it's not just one simple smart contract. Yeah, so that is how smart contracts are, and that's how complex it can get. But it is not very complex for us to implement many more, right? So, and what happens is you have three types of players or stakeholders in Maker. You have a governor who then governs and tells and votes and tells you that these are the policies we will vote on, and this is what they should be doing next, and what the roadmap should be. Then you have maintainers like coders and guys who run the smart contract. And then you have users like you and me who would want to buy DAO and then bet on it. Yeah. So that is Maker for you. And very, very successful in its implementation. So these are the two awesome examples in our real life where smart contracts have hit. I know you guys have come here for procurement and supply chain, but this gives you a good idea that the world there is infinite possibilities of implementing it and not getting stuck with a few nuances which we might have. Yeah, cool. So with that, there are some implementation challenges, right? Nothing is fully hunky-dory. All great stuff talked now, but let's talk about some challenges which we have. From yesterday, we've always said smart contracts are like Superman. So nothing can beat it other than kryptonite. And this is the kryptonite it has now you need to be worried about. So the first one is standardization. There are so many experiments happening. It's in the early days that everyone has their own version of it, right? So I love Python. Can I write it in Python? I love Solidity. Can I write it in Solidity? I love JavaScript. Can I write it in JavaScript? So everyone has their own version. Every platform has its own view of it. And everyone wants to do everything. So there is no standardization yet. And we need to bring all of them together and standardize this so that they can become much more easier for us to look at. I'm not saying that it has to come back to one standard. It can be a couple of standards, but it has to collate itself into being using a very couple of languages only, using couple of platforms only, and then ensuring that there are people who can adopt it, right? And then making it very easy for it. So that's that. Then the second one is security. We have a lot of problems with security, right? And we spoke about it a little yesterday. But I want to talk to you about a story. And this is a story which we've been hearing from our childhood days, where there is a shepherd and grazing his sheep, and he always gets bored. So he goes on top of the mountain and starts shouting, "Lion, lion," or wolf, whatever you guys like, a wolf or a lion. Take your fancy towards it. So he keeps shouting, and then the villagers come running, and then they find nothing. And then again, a couple of weeks later, again he does the same thing, and he has his laugh out. And then really a tiger comes or a wolf comes, and then he shouts, and villagers come to rescue him, and then he gets eaten up too, very sad, and his sheep. So the same story is applied to the first smart contract or DAO which was written. This is called the DAO hack, and that was the first security hack, right? And it's the same story. Now you can relate it. So when the blockchain came out and then they said smart contracts, everyone felt foolproof, Superman, nothing can beat it. Whatever we implement is going to be super secure. So whatever crap I write, it will still be secure. They were so arrogant and so confident about it that blockchain hai to kuch nahi hone wala. So, and then they went and implemented the DAO. And the DAO's premise was that it collects money from multiple investors. You get a pool of money, and then you invest it on anything you want. And then like any other DAO, you had a voting mechanism to say, okay, we will invest in A, B, C, and then people used to vote and say B, and you voted on B, right? And this one all was written in the smart contract. Now, these guys were super arrogant, super crazy, and said, blockchain, nothing will happen. Then one of the guys said, you have a error, or there is a loophole in your code. Please don't release it or go and fix it. These guys said, bullshit, nothing is going to happen. It's blockchain, it's smart contract, what will happen? And then they let it in, and the guy exploited it, and he took out $50 million out of it. Just one single line of code, and that killed the DAO. And it also created something called as a fork in Ethereum called the Classic, and the one which we use today. Because they were still so arrogant, they said, nahi, piche jayenge, but blockchain chhodta nahi hai to go back. So purists remained with Ethereum the way it is, saying that it was your code, it was not Ethereum. The guys who lost 50 million said, we'll create a branch and we'll go back and get our 50 million, because go back some 20 blocks back and we'll say nothing happened after that. So that was the DAO hack, right? Now, so that's a big problem with smart contract. I'll just show you one example, right? So if you go to etherscan.io, and this is what is happening on the fly, right? So if I take the latest transaction which has happened and I click it, okay, this doesn't have, so let me go back. I'll take the second transaction. Okay, this has the thing. So I clicked on a transaction, it says this is the transaction, and so on, right? So if I click on the one of the things and then go to contracts, and I can see the entire code here. So it is open to everyone. So it is not kept closed. So everyone knows what you have written. So this is how the DAO hack happened. So you have written a code and people can see it. Oh, this is of course public blockchain. If you keep it more private with the enterprise blockchain, maybe you can't. But what I'm saying is the security is a big concern. When you implement it, you need to make sure you're 100%, you've tested everything, and it's foolproof. And that is what you need to do when you write your smart contracts. And everyone can see it, right? They're calling another smart contract and so on. So you can click on it and then figure it out and so on. So you can read the entire code. Nothing is top secret. So can Coca-Cola recipe put on smart contract? No, because everyone can see it. And that is the biggest security concern which we have with smart contract, that the source code is accessible, people can see what's happening, and then they can take a decision, right? Then comes scalability. Though smart contract is not directly related to it, but smart contracts trigger something called as consensus so that everyone has to agree, and that has a problem with scalability, right? And can I do thousands of transactions on it? No, not now. At least when yesterday we spoke about 160 transactions per second. Those are all lab driven, but when it comes to real life, we can't achieve it. So there are experiments going on and we need to work on it. So again, when you're writing it, you need to make sure take the use case, figure out if this use case requires a real smart contract or not. If it does require a smart contract, does it support your performance you require? And if it meets all of those, then you implement it. Otherwise, go back to a traditional database with three-tier architecture. It does a wonderful job. So the biggest challenge in my career, at least when I'm as a lead or a person who talks on blockchain, is to say, don't use blockchain. 95% of the time I tell my clients, blockchain is not right for you right now. And when I say no, they want it even more. So that's a sad part, but that is what it is. So that's scalability. Then you have privacy. As you saw, you could see who, it's a pseudo privacy, right? So I can, if I go back to my Etherscan, I know from where did it come and where did it go. And you can see all of those. And if I know exactly who the wallet owner of this is, I know who it is. So that's another big problem with it, right? Because it's open, and if it is public, you know it. And in enterprise, there is nothing called as private until and unless you put a channel and so on. But you already know who those players are. So privacy is a big concern. So you need to look at how do I address privacy. And there are techniques for it nowadays with zero knowledge proofs and so on coming in, which can handle privacy. But as of now, it's still a very complex problem to solve. And the final implementation challenge which we have is debugging. Now, you heard this nice story of me about the DAO hack. How do I debug it, right? In a decentralized, distributed computing environment, how do I debug it? Debugging it even in a normal single computer itself is like tricky. Now you have it all over the place, and I have to debug it. Is even more crazier. So while implementing it and making sure that this is all foolproof, debugging becomes another big challenge in the computer terms. So these are the implementation challenges. Now let's look at limitations. Yeah. Limitations, though I said MakerDAO is complex, but it is well defined and it's in the boundary, right? I have a token, I have a crypto which I deposit. There is no ambiguity in it. There is no delay in it, right? But in our supply chain and in procurement, there is always some delay. There is always some external factor which has some new nuances which bring to the table. How do I factor those in a binary terms, right? That becomes a very, very challenging limitation for me. And that is when yesterday we spoke about that we need human oracles, you need external oracles, and so on to then look at the external interfaces and external nuances to be brought in to do whatever we need to do to get a deterministic answer. And get a deterministic answer that whatever code I run in whichever node across the globe, the answer needs to be the same, right? If 2 plus 2 is 4, everywhere 2 plus 2 needs to be 4. Right? If someone gives 5, that means we don't come to consensus and then we can't run it. So ensuring and getting that complexity answered in the cases of procurement and supply chain is a little more tougher. So we need to think about it in a wider gamut and say how do we address it, and then write smart contracts which are very, very easy to implement and easy to adopt. Then comes your disputes. Right? Anywhere you have humans in it, you have disputes. You can't live without it, right? Let it be family, let it be organizations, let it be anything else, you'll end up with disputes. So your smart contracts are interfacing with real life where humans are working, and disputes will happen. Though we say that the disputes can be reduced to bare minimum, but disputes are still there. And when you have disputes, how do I handle it with smart contracts and blockchain is a big question. And that's a limitation. And we spoke about, again, human oracles to come in and then try and solve that, right? And you need those external interfaces to come in and then help you with it. Then comes your regulation. Not all governments and regulatory bodies are up for automation, and the politicians and others in the bureaucracy are not yet ready to give away whatever they hold dearer to them. So till the regulations become okay, and we still don't regard smart contracts legal yet in most of the nations, right? In few of the places, they are just an enabler to help you with the proof, but they are not fully legal contracts yet. So regulations need to catch up, and that's another limitation. Can I implement it? Yes, no, can't say, right? And depends on the regulation. And the last thing is flexibility. How much flexibility do I have? So one of the cases could be, okay, I've ordered 10,000 shoe pairs, right? And I ordered all of them white, but then they sent me 100 of them blue. Now, how do I create that flexibility in a smart contract which is expecting everything to be white sneakers? So that's the flexibility we will lose, because it's a very confined binary of yes, no, right? And that is when you need to now, I'm not saying it can't be done. Now when you write a smart contract, you need to be aware that you need to think of such exceptions which are there, and then write and accommodate to that exceptions and that flexibility. That is very, very critical while writing your smart contracts. Okay, so that ends our limitation. Now let's go to intangibles, right? All of these are tangibles. You can see it, you can feel it, you can work on it. Now, the intangibles, which are future dimensions which you now need to look at, is governance. And we spoke about DAOs, right? So how do I govern it? Who has the right to modify the smart contract? Who can then accept it? How does it get accepted? What should be my roadmap towards modifying it? Are all very, very, very important. And then governing it. So writing a smart contract to govern another smart contract is not practical as of now, but we need to look at it too. And those are the intangibles you need to think. That is where you have things like creating a special purpose company to maintain the blockchain environment, right? So you create a spin-off company, you have all the big brothers coming in and then agreeing on it, and then they have the administrative control. At least in the private side and the enterprise side, it made it easy, but in the public and permissionless, it becomes much more crazier. And that is when the game theory and all of those need to come in, where you're motivated to then not fool the system, and that's very important with the governance. Then you have interoperability, right? So another question to you guys on your Menti. Hopefully you've not forgotten your mobile buddy. So go back to your mobile buddy and answer this question. How many large blockchain networks will be there in future? You think 1, 2, many, 5, 3? What do you feel? Yeah. Like everything else, it will consolidate into 2, right? Pepsi and Coca-Cola, Uber and Ola. So, but ultimately it will be many, right? So if you have multiple blockchain networks in the world which will operate at different industries, what do you think the biggest challenge will be? To talk to each other. If they don't allow it to talk to each other, then it will become a problem. And that is where the interoperability comes in play. And that's an intangible right now. That's a future thing which we need to answer. We have done so many open source programs. The startups are working on it to make the interoperability much more smoother. Double spends become much more crazier because you're spending it in, you're minting it in one network, you're spending it in another network. How do I ensure that you don't go back to your original network and spend it again on another network? So all of these are complications which will come in. And how do I ensure that in future, when you have multiple big blockchains which the world will operate on, can talk to each other? Yeah? Cool. So then comes AI. We spoke about it a little yesterday. Our friend from NITI spoke to you yesterday, and Dr. Samsundar had a different opinion on AI being with blockchain, but this is going to come. How do you enable it? When do you enable it? Can AI write a smart contract based on certain things, right? You're never writing a smart contract. Smart contract is written by an AI based on what it is and deploys it and then executes it. All of those are possibilities of future, which is very critical for us to embrace as we go in. And the final one is sustainability. Today, everyone is talking about sustainability. Yeah, I went and bought an electric car because of the peer pressure I had. I'm not a tree hugger, but I had to buy it. So sustainability is a very, very important aspect, and blockchain was notorious for it until recently when Ethereum went to POS. And now everyone are thinking and talking and doing everything they can to ensure that it is much more greener. So again, open up your mobile buddy, phone a friend, and answer this question. Do you think blockchains are much more greener now? Yes, no, yes, okay. Bitcoin can never change, it will still be as power hungry as it can be. It's like the Bakasur of our ages, keeps on eating, sleeps, never wakes up. It never went back to 90K. Made me poor. Cool. So yeah, we are getting closer to it. There is a long journey for us, but sustainability is a thing we need to think of, right? I keep telling my team, when we do Teams call or video call, right? We keep saying that, hey, you traveling on a flight to another place like this and doing a physical conference versus me doing it on the video. Now the video, the carbon footprint the video enabled has, because of the internet, because of the power we need to give, so much of data has to flow in back and forth. All of that has to happen in between. It's almost 50% of what it would have if I had taken a flight and come. My footprint is almost there, right? We would have thought, okay, array video on kar liya, chal jayega, but the video, you're turning it on, you're laying that cable, the fiber optics, the plastic which goes in. If you take all of those in account, it is almost equal. So using and traveling is still okay. So sustainability is important. You need to look at it, and is a very important dimension for the future, which is intangible. With that comes our benefits, right? I gave you a glorified blockchain, smart contracts. Then I said, what are its problems? Now, Eileen, let's lift our spirits up and say, we should look at smart contracts. The future looks really bright for smart contracts, starting with intelligence. Yeah, so you can automate things, you can make it more intelligent, you can use AI on it. You don't need manual interventions and so on. So it is very, very critical for us and the future of smart contracts that we start building intelligent smart contracts. So we'll coin something new. We'll call it ISC, Intelligent Smart Contracts for the future, yeah? And then transparency, yeah? As we go and build this, we want it to be more and more transparent in our life. We don't want, if you look at governments today, right? The entire reason we brought in this entire concept of government is to ensure that we know what our public servants are going to do for us, right? But it's now the other way around. They know everything about us, but we don't know anything about them. So if I spend 5 rupees somewhere else, they know it. If I don't pay my income tax, they know it. So the surveillance is ulta. We should be seeing what they are doing. Instead, they are seeing what we are doing. So ultimately, we want to make sure that the smart contracts or the DAOs we put in ensures that transparency is both ways. It's just not me giving my privacy out and transparency out, but I want to also see what they are doing for me. And with smart contracts and stuff like that, we will get into it. Okay, then comes efficiency. No brainer. We've always talked about automation, and smart contracts can get executed if certain preconditions are met and so on. So efficiency is definitely going to be a game changer as we go in. And as we go into the future, the exceptions are going to be lesser, right? For example, if I go into a restaurant, I know now it is going to be neat. They are going to give it to me in a plate. They are going to give me, there are only 5 paneer variations you can do. That's it. Now we have hit all the kinds of things. So all your exceptions are almost gone. You know a standard operating procedure, you will hit a 99% without exceptions. As expected, you will get it. So there will be no exception. So efficiencies will only increase as we get into it. Then comes security. We spoke about it. And how do we address it is a question. But we will definitely address it. We are getting smarter in addressing it, and I'll show you a solution for it on how you can address security in the future. And we also talk about quantum crypto, right? So today you're saying whatever keys you use can be broken by the quantum crypto later with quantum computers. Can I avoid that is the question. So yes, you can with quantum crypto, post-quantum cryptography in it. Then comes programmability. We all spoke about CBDCs. Tomorrow when CBDCs are implemented all across the globe, I want programmability in my smart contract, or allows me to do it, right? So, yeah, it is asking me to breathe also, intelligent. So if you take these coins, and then I want to, like, let's take the vaccination, right? So we gave you some kind of subsidy saying that you go get yourself vaccinated, and we said here is the thing, or your LPG, right? Now I can program it in the smart contract that this has to be spent only for certain things. Now I give pocket money to my kids, then I can say use 50% of it to buy books, 10% to eat chocolates or whatever food you want to eat, another 20% to watch a movie. I can program it, and I don't need some, and we are already talking about softwares which are low code, no code. So you don't need to worry about you understanding and coding. You just have to drag and drop. So the future wallets will be that when I give kids my pocket money, I program it to say, okay, only can buy books. How cool will that be? Or when you're given your salary by your employee, then you say you can't spend it on something else and spend it back on their own products. So, and then finally cost saving. Because you're doing all of these, you will save cost, and these are the benefits, and the future looks very bright with all these 6 elements. Now let's go to solution, and this is my last 5 minutes. I know I've taken some extra time. Swati might have to hurry up a little more on future, I guess. So the solution is pretty simple, right? And we have these 4 big problems. We have standardization, we have security, we have privacy, we have sustainability, and we have governance. So if you keep these are my limitations and challenges of smart contract as I go in, what kind of solutions or what are we working right now to eliminate or negotiate or do a workaround around this? The first one is you have external auditors like Certic and SciStack, which can audit your smart contract before it goes in, right? And you get a little more comfort saying that whatever smart contract I've written is much more reliable, is a little more non-hackable, right? And you get it certified by them and saying after they go through a lot. So if you start doing those, then you can look at standardization, because there is one body looking at it, and then you could go closer to a standardization method. Or you could, because it is what it is, it gives you security. It can't give you privacy because you're exposing your code to another person to certify it, right? And of course sustainability, because you can enforce them to look at certain things and say you could write a code better. Instead of calling something, you can call something else, and making it a little more CPU free or memory free, so that it doesn't burn too much of power. And then in governance, because you're going to a central auditor, you can put some kind of governance in it. So that's one part. The other one is interoperability. You're already looking at Polkadot, Hyperledger, Cacti, and so on, which helps you do interconnections or cross blockchain network connections. Yeah, and that is where again you can see that standardization, security, and governance can be answered by it. Yeah. Of course, privacy and sustainability goes for a toss because instead of now running one blockchain, you're running 5 blockchains because you need interoperability between them. And privacy also goes for toss. Now your data is not just exposed in one network, now exposing it to 2 networks or 3 networks. So that is where it goes for a toss. And then privacy preserving techniques like you want your privacy to be handled. There are techniques like zero knowledge proof, Zether and Zero Cash and Zero Coin and all of those, which are implementing certain things like this homomorphic encryption and all of those, which can address your privacy. And then finally, you have newer consensus coming in like POS. And there is the newest one called proof of space, which is also coming. So I'll leave that as a homework. Since we are all in the academic region here, I should give you some homework, right? So why don't you guys go and Google or ask ChatGPT what proof of space is and learn it for yourself. With that, thanks a lot. I really appreciate you hearing me out with your left and right brain synced. Thank you, and open for any questions.
In future, which platform will be more useful or adaptable by industries or government, like private, public, or hybrid?
We spoke yesterday, hybrid. You knew the answer anyways. So hybrid is what I feel should be.
Why?
Because you want certain things to be exposed where the world can see, and you want few things to be secretive to a certain organizations or within the organization. And the hybrid gives you that ability to do both and get the best of both worlds. And if you take any government work right now, it's all black box, right? And you want to expose only few things out, and you want to still keep few things in. Hybrid allows you to do that.
Okay.
So, yeah.
Thank you, sir.
You need to. Yeah, you can take this. I'll take the other. No, I'll be at the.
Sir, is there any regulator as of now, or anybody certifying this one, these smart contracts, like we have, say for the food FSSAI or something for ISO, and for this one also, so that people get the confidence that yeah, it is trustable and we can go ahead with that.
Okay, so the idea is to take the industry standards and then apply it or write it in your smart contract, right? For example, for supply chain, you have GS1 standards, which you can bring onto the supply chain smart contracts and the data standards to bring that in. And from the security perspective and all of those, you have companies like Certic and SciStax to help you certify them. So as we go into each industry, let it be pharma or health or food and stuff, you should just borrow the standards from there and then start implementing. That's the quick win. Ultimately, they will all converge, and then we might have a standard which an ISO or W3 or someone will write it, and we'll have to follow it. But for now, one thing which is happening right away is the digital identity. So you have W3C writing that standard so everyone can use one standard for identity. We will see that for every industry as they all come together and the adoption happens.
Right. Thank you, sir. And one more thing, sir, that transparency, and you have written that trust less earlier. So
Yeah.
why shouldn't it be trusted or trustworthy?
Yeah, trustless. Even if I don't trust you, when you execute it, I will end up being happy, right? So it has to run in a very trustless environment without any extra work, and that is why it needs to be. So when you write your smart contract, even if a hacker gets it, you should be okay with it, and that is why it needs to be trustless. That whomever gets it, you are pretty confident that it will run.
So on the other way, it is trusted for me, but for
Yeah,
everyone else.
as soon as you let it go,
So then it is
so when you
trustless.
let your pigeon go out of your net, you're thinking that no one will shoot it, and then you hope it will come back to you and have your chana later. But yeah, that's what it is. That is why it is trustless.
Thank you, sir. Thank you so
Cool.
much.
Yeah.
Yeah, we have a lot of people from public purchase over here. So, and public purchase, there's a huge element of ownership of responsibility and fixation of responsibility. So, in a smart contract like environment, would if something goes wrong, is the policy maker or an internal, a senior official in the public enterprise responsible, the coder responsible, or the auditor responsible?
All.
So, so
That's the most
fixation of
modest
responsibilities.
answer I can give you.
But that's a very practical problem.
Correct. So it will end up being that, right? Because nothing is perfect. Someone will find something. The answer is being as flexible as you can to change it very quickly, look at it, and then address it. So you will end up having problems because you wouldn't have thought through everything. So everyone, and that is why you need a special purpose companies to run the blockchain network, so that if the indemnity or any such clause comes in, it is limited to that company and not everyone else.
And that problem will get overcomplicated when we bring in AI with it.
Exactly. But also get restricted if you do that, and you don't know. Wait and watch.
Yeah.
Yeah. Cool.
Excuse me, sir.
Then initially we were told that third party is not required. So again third party will be required, these lawyers and everyone, because the responsibility has to be fixed, and then again we'll be going to the court.
So never we are going to get eliminated with the intermediaries, but the role of the intermediaries will come
Brought
down,
down. Okay.
or it will get automated. But in few cases where the exceptions are there, you will need someone to adjudicate that, right? And that will still be there. But what this will bring is a strong audit logs which are immutable, which cannot be changed. So you can say, if Deepak executed this, he used his private key to execute it, he can't say, I didn't execute it. I might have executed a wrong thing, but I can never deny saying I never executed. So those are the things which you bring to the table. And there are still problems which will never go away.
Yeah,
You'll still need someone. Hopefully 30 years from now.
Yeah, and
we
the
will-
overall, my observation is the way, because we are from Sports Authority of India, both of us, and we are into sports, where the human touch is much more important. Physical
than-
activity,
yes.
sports.
Yeah,
is.
exactly.
So my observation is that gradually we'll be absolutely, the interaction, the compassion, is going completely. It will be
Away.
completely away. It will be completely machine. This.
So why don't you think it this way? All your administrative work which you have to sign 10,000 papers, go and submit something, which is taking away your time from being closer to an athlete and motivating that person, you will get all that time back to be more connected to that person, because all of these will be automated, and you will do the right thing
That
for
is
that
true.
person.
That is
so.
We'll be able to
that's
squeeze
the
out more time
positive-
for the athletes that way.
That's the positive I see.
Yeah, right. Thanks.
Yeah.
Yes, sir. One more thing. You told your system is not foolproof. Somebody lost $50 million for in this process. Okay, so why you are wasting so many brilliant minds and money for this to lose $50 million? Instead, you can use your brains to eradicate poverty or to educate people.
How can I answer that question? Uh, Rich people do rich things, which we can't understand, I guess. Um, Again, the idea was to collate money from different people, right? And then run it in a way which is more democratic in its nature. Uh, the idea is, and if you go and now look at UN, the 16 SDGs, and most of the places blockchain now plays an important role. And when blockchain comes in, smart contract is there and is trying to solve world hunger, vaccination problems, serialization. All of those are happening. But the economy itself is like that the rich do what rich do and poor do what poor do. And there is a flow between them, which is unavoidable. Sorry, I don't know how else to answer that.
Okay, thank you, sir. Thank you.
Deepak?
Yeah.
Here.
Okay, yeah, there. Okay.
I just agree with what officials from SAI has told. You yourself has given the example of it is better to travel than to do the work through the video conferencing.
Yeah.
And really it's going to be a very tough world now
Of
in the
course.
coming days, though the things are automated now and it's going on. But one thing I just would like to know that you have given the example of some hacking done for some $1 million in one of the case. So then who bears that loss? Whether all involved in that blockchain or
Have to
or
share it,
everybody,
yeah.
every stakeholder? No?
Now, like, for
So then
example,
there
the
is a
bank
great
went
risk.
down.
Uh-huh.
All the players in the bank with the SVB are facing it, right? And the government will then come in, and then you are the taxpayer who has to then pay an extra tax for it to
Right,
then
yeah.
bring it back to the normal thing. So everyone in the network bears it. That is why you had this fork. So people said, okay, we have to take it with a pinch of salt. You guys did a foolish thing. We will continue, take that 50 million loss. And some of them were arrogant and said, no, we will just roll back few blocks and then start another fork and where I'll get my 50 million back and then I'll do what you want. And no one supported them. And they are defunct, almost defunct Ethereum Classic. So, yeah. One more and then I have to let my colleague also talk.
Just to these two earlier questions and a corollary of that, the fact is that you said with so much regulation and automation, we'll become more efficient, but don't you think as human beings we'll become unsmart? Because the point is that, we won't be able to apply ourselves in individual cases which need human intervention.
Again, when the computers came out, we were all very afraid that it'll take our job off and then we might not have that human interactions and so on, right? And then we did that with the digital thing too. When we said, okay, video conference came, we might not travel, we'll lose the face-to-face connection and so on. So you'll always have that challenge and that apprehension in your mind. But we as humans have the ability to work around it. Like what I was telling the gentleman is, now you have more time. Now you invest more in, than doing the administrative, moving paperwork, than doing the real work where you're helping, looking at the athlete and then taking help. So I feel we will adapt to the newer technology to give us more time. My question is, we'll have so much of time, but our productivity will be so low that we don't know what to do. That's my big apprehension. Right now only we are like spending so much of our time scrolling on social media, which is meaningless, and we are addicted to it. Now if I take off half of your work, you will do more of these nonsense bit. So which is a bigger challenge than I'll not be able to do something for me. So that's a bigger worry. Hope that answered. I'm becoming a Sadguru here, giving philosophical questions than technical, I guess. Okay, thank you, and I really appreciate your time.
So now requesting Dr. Madhuranjan Kumar to hand over the memento to Sri Deepak Lalan. Thank you so much, sir.
So finally, thanks a lot.
Moving on to the next lecture. It will be delivered by Mrs. Swati Bide. Mrs. Swati Bide is the leader of Asia Pacific Blockchain and Automation Global Innovation Unit at IBM India. She is also the IBM partner leading the blockchain and automation unit across the Asia Pacific market with experience delivering more than 100 blockchain projects. She holds a management degree from IIM Bangalore. She is a banking industry expert with almost 2 decades of consulting experience. So I request her to please come onto the stage and deliver the lecture. Ma'am, please.
After all the multiple questions of blockchain, I thought I'll give you a breath of relief over here. See all the technologies, right? I think just one thing, I know all of you are procurement experts here. One disclaimer, I am not a procurement specialist, so if I do any mistake, please help me around. My real job is basically use any of this to help our customers in any of our industries. However, of course, banking is my core industry. I end up looking more of why did SVB really fail? Where did regulators have an issue? What was the difference between 2008 global crisis versus now with SVB? Does anybody have an answer to that? What was so different, or was there anything different in SVB fallout than what we have today? Do we have an answer? Actually, it was one of the very old schemes. There wasn't anything new that SVB did. From what I'm hearing from most of the places, it's basically the regulator's role that failed, right? The regulator's role in the sense that the regulators or the supervisory bodies today are more focused on process compliance than actually finding on those loopholes. I'll ask an easier question. Why did our Indian IT provider CEO resign? Is that an easier question? No, I don't have an answer to that. I think all of us are struggling with that. Why did he resign? Anyway, so I'll take a pause here. The reason I bring this picture up, and I think one disclaimer again here, this was before ChatGPT was officially launched. Otherwise, you would see all ChatGPT and AI everywhere, right? I think that's the hype we have today. But amongst all the technologies, I know that you heard blockchain and smart contracts so often. But this is the paradigm of all the technologies that exist today. And this is again based on AI. The clusters that you see is trying to tell you what is being talked about more, what is being worked upon more. So you see those different colors and different sizes. More or less before ChatGPT, I would say, quantum computing is still being the number one being talked about. Security in many, many aspects. Blockchain also comes as part of that security. And third is automation. And automation can be in any way. It can be the smart contracts that we talked about. It can be robotics. It can be anything and everything. But automation is absolutely something that we're talking about. Automation also comes because of digital transformation that we are seeing in our own country today. And again, digital transformation is because the self-service is something that we all have learned to do, right? So they're all related in one way or the other. Just a quick jump, and I think all of you are from different enterprises. I don't need to say this, but you know, from the way that we used to work in 2010, in the silo to today in 2020, a decade later, we have, you know, even if I just take a simple example of data and AI, we used to work in different functions, data AI. Now we're talking about data AI across the enterprise. And the third that is going to come and is already there is we are talking about the automation that, and the DAO that Deepak talked about, right? So it's absolutely automated in most of the ways. I know we have concerns about, you know, what does it leave with us? But it's the same thing. While ChatGPT is so good, you know, you can get all your answers. Of course, our teachers and professors have concerns because the students will write their essays in using ChatGPT, right? And I have a daughter. Obviously, those are the questions that will be there in each of the minds. So good or bad, but this is what is there and is coming. From a supply chain perspective, and this is not far, we're talking about 2030. First of all, we are saying COVID, when it came, we all know the issues of, you know, the oxygen cylinders, the hotel beds, the vaccines and all of that. One thing it clearly exposed is the vulnerabilities that exist in our supply chain. That's the most important thing. So it's essential that we connect most of them. If there are things that will not be available, we need to know beforehand. If there are things that cannot be met, we need to know beforehand. So all of these vulnerabilities is going to make sure, for that, we have to know that they have to be connected. That's the most important part. Secondly, cloud adoption. I know there is a lot of discussion about cloud. We also have from our regulators many regulations that are coming out of it. But the moment you put it on cloud, it makes life easy. So that's another trend. Data, AI, we spoke about. And sustainable, there's been a lot of. I will skip some of these. But this is just a quick glance from a McKinsey, which says what will be a supply chain leader. And I think a lot of you, from a procurement function to a supply chain function, will be a part of this, right? So what happens? First of all, you concentrate on your customer, not your internal process. Second of all, it has to be data and AI driven. Your supply chain has to be sustainable. And I know I heard a lot of questions on blockchain, and I'm sure you have 10 more questions on other exponential technologies. But a leader will ensure that these technologies are really embedded in your solutions so that you are prepared for the future. A very simple example of what the supply chain collaboration will look like. What's most important is the ease of business. The ease of business with you, the ease of business between the parties at the bottom, right? That's what we are all looking at. How convenient it is, and you know, why do we all love Paytm and UPI and Google Pay? Because the easiest thing to do is that. You know, how much of net banking do we do versus the Google Pay we do today? It's simply because it's ease of business. Reduce the friction. You know, there is, and COVID obviously was a very classic example there. There is multiple frictions that come in a supply chain, and I'm the last person who should be telling that. You know it very, very well. How do I reduce the friction? Now to come to that, why do we need to do all of this also is because we need agility in the system. As you said, that if you had 100 shoes that you had, or 1,000 shoes that you had ordered, which was supposed to be white in nature, and the blue came, 100 of them came blue, what do? So you need to have that flexibility and the agility in the system. The systems of tomorrow, and actually even today, are all going to be multi-layered networks. How well you connect to those multi-layered networks is the crucial point. How much of an advantage that you take with your connectivity is where you succeed, right? And I'll give you a few examples, but that the larger your network and reaches, the stronger your business and easier in terms of working through it. What do you need to do for both of those? On one side, you have to make your business model flexible enough but strong enough to be able to use all of these different technologies to come together. Smart contracts, we heard a lot about it. How do I use smart contracts to do this? How do I use data to do this? How do I use AI? How do I also use interconnected solutions or IoT for that matter to do it? That's going to be crucial. And then on the operations side, how do I make it more efficient? The reason I bring this, it's a very simple chart, it's not technology-wise, but you have to come to a stage like this for the future virtual economies that will exist. Again, this is the CPO agenda for procurement, the Chief Procurement Officer, for your future. What should you look at? From your disconnected to collaborative, where partners are more like peers. From your tactical to transformative, which is absolutely, technology is part of it. India has been excellent in adopting technology, and we've really leapfrog only and only for that reason. I think it's essential that we do it here as well. From gatekeeper and all of that to self-service, I think we need not talk about self-service. Self-service is something that we've all got used to it now, but it will move in that direction. Even in any of the supply chain, compartments that we talked about. From transparency, lack of transparency, you have to have transparent. It has to have visibility, auditability. From your spend focus to insightful, and of course from being adaptive and agile. From the workforce, I just get the mix of workforce only because the models are completely changing. How people will interact in the office, from your workforce somewhere remotely, they'll all be very, very different. So how do you get adjusted to that? Now, this was just a context that I wanted to set, and I will, with all of the discussions that we had, I'm going to skip a few. This is just one example, and this is example, sir, to one of your discussions, and the focus is not really on technology. It doesn't matter whether it's blockchain, it's AI, or whatever that it is. But essential is if you automate the parts that are not crucial for you and keep the strategic ones with you, that is where the impact is. So for example, we for our own, and I'm from IBM, sorry, I'll just repeat that. We actually automated a part of procurement, right? What we automated was the review part of it. Every contract when it comes in, how do you review it? How the hierarchies together, how the different contracts are connected. We just automated that part of it, right? While you've automated that part of it, the rest of the team is actually now able to connect more and get more revenue on the other side for us. Right? So that's how you have to look at it. When you get technology, you're actually bringing technology to let go of the work which are not strategic in nature. That's the most important thing. Now, this is something that I wanted to show was because we talked about smart contracts a lot, and there was an Australian blockchain company that was trying to create contracts for the build the smart contracts for the legal agreements that we have. So we have, we do a rental agreement, or we do an affidavit, or I do a complex contract which is binded by the law. Their objective was, how do I create that of smart contracts and how do I legalize it? I think creation is much easy, legalizing is much difficult. So they had a combination of a legal entity which was called Herbert Smith Freewills and multiple other parties. They also had a regulatory. Now I should tell you that this didn't fly completely. They did a lot of things, but did not fly because of a lot of limitations Deepak talked about, but most importantly, this was tried like 5 years back, so it was much, much early in the game. But the concept is very strong, you know. What we are talking about is everybody gets the same truth or the single source of truth of that contract. Everybody works with that same contract, right? And you know, one of the examples that we also had was bank guarantees or the lease kind of agreements that you have. It happens, you know, let's say you have a 100-year lease. After the 50th year, something goes wrong. Who remembers? The person, the two entities who did it does not even exist probably. They don't live anymore probably. How do you go back and check that? So in those cases, it's very important that there is some sort of truth that everybody can look at, right? Automation, I don't have to say, but then all of these parties, which is contracting parties, government property, government departments, law firms, all of them coming together, they actually were responsible to get this smart contract up and running. Now this is in your space entirely. I don't think I need to explain this. The essentials is that if I have the suppliers together, if I have the purchase orders that everybody can look at, if I have the goods received at one place with no disputes at some level, and if I have, not the essence, but the contracts itself, the contract agreement between the two parties, and my goods received and the invoices, if I ingest all of them in a place that you can see it, that everybody can have a view to the common thing, it's much easier, right? What can I do? Deepak talked about traceability, visibility, auditability. Of course, all of you are seeing the same thing. While somebody can say, no, I shipped 100 items, but 50 of them went via a different logistic vendor. You can say that, but you can't say that I shipped only 50 and I did not ship another 50, I don't know where it is. Even today, when I'm having a Swiggy a Swiggy app that you go to, you've ordered food, you want to see how quickly it'll come to you. You also want to see where it is at this time. With something like this, when you're used to Swiggy, you also want to do the same for your any kind of purchase. How do you do that? This is the only way to do it, by getting them connected. Again, I'm repeating, the connections does not mean you have to do blockchain and only blockchain. There are many, many technologies to do it, but blockchain is an enabler to be able to get that connected for you. Simple examples which I have not put in here, but let's say you went to Reliance Smart and you bought you bought a box of Kellogg's which was wrong. How do you trace that Kellogg's pack, and how do you make sure that that Kellogg's pack of yours which was bad, there could be another 50 in different Reliance Mart, and can I pull this off? Can I get them out of the shelf? The only way to do it is, if you know where did this Kellogg's, which distributor it came from, where was it sourced from, and I have that traceability and I say, okay, this distributor, which came from a manufacturer X, this line is bad, and hence remove everything, all the numbers of Kellogg's pack that came, which was associated with this line. That's the easiest way to do it. Otherwise, obviously, it might take like 7 days or weeks for you to be able to do that. I will skip this. But the only thing that I want to say also is that you have your ERP systems. The ERP systems continue to be there. We're not getting rid of the ERP systems. They will still be your system of record. What you're saying is the important data out of there, you're going to put it on the ledger. That ledger will use that data to create smart contracts, which will actually create the automation logic for you. Right? The system of record does not go. The system of record exists the way it is. This is just one example, and I'm just putting this across because we worked for one of the large supply chain companies. And from this 90 to 60 days that it would have to handle the disputes, I know Deepak mentioned disputes will never go away, but can definitely come from 60 to 90 days. It actually came down to 1 day. You can, from any point of the starting to end, you can actually resolve, close that dispute in 1 day if it has occurred. Of course, will you need human intervention? Yes, absolutely, you might need. And that's essential. We exist for a reason, right? It will be there. We talked about sustainability. Now, if you are connected, and only if you are connected, you will be able to figure out all the parameters of that supply chain. Now, do you understand scope 1, scope 2, scope 3 kind of emissions? Does anybody or everybody understand that? Okay. The laptop that sits here, how do you know how much carbon this laptop has actually generated? Not why I'm using it. While I'm using it, it's a different ball game. I'm talking about the manufacturing of this laptop. How much of carbon did it actually generate? What is scope 1? You bought it from what brand is this? Dell shop? You bought it from Dell. That's a distributor. You first find out in that Dell, what is the carbon emission that's happening at that first level? The Dell got it from some manufacturing, so that's scope 1. The Dell got it from a manufacturing unit somewhere. The emissions that are created there is scope 2. And the parts that are there in this Dell computer came from the chip has come from somewhere else, the other parts of motherboard has come from somewhere else. That is scope 3. The only way you can come to know the emissions on each one of them is that if this chain is connected. And if this chain is connected, you can get the carbon footprint at each one of them. And the carbon footprint has variety of parameters. It's just not about how much electricity I'm using to how much water I'm using. It's 10 other parameters to look at, right? So that's how you figure out how you have come, how sustainable this product is. And from a finance perspective, and I think there are some people from the finance, World Bank and some of them. From that perspective, the big thing is about you should do maximum sustainable financing. For me to be able to do sustainable financing, I need to know how sustainable this company's product is. And that's the only way you can do it. Right? So that's one of the big things in the future that we have to look at. And then, of course, from the manufacturing and then back to the scrap. My Dell laptop, once its lifetime is over, I've given it to scrap. What happens after that? It's my recycling that it goes to. How much of a carbon footprint that recycler does? As far as you are connected, you can get these parameters into it. I will skip this. This only talks about multiple data that needs to come from there. So when we talked about the recycling, I will shift from okay, you know, it could be a plastic bank or it could be an electric bank, whatever, doesn't matter. But basically, once the life is over and you are recycling it, what does it take to recycle it? Right? Once, and this simple example is a plastic bank because this is the plastic recycle that we're talking about. Every time a collector gets the plastic to you, they are given a token. Again, a token is the form of, one of the forms that Dow talked about, one of the forms that, you know, you can give it as in the DeFi concept, but it's a token that you are given, right? This token, this token when I've got as a collector, how do I make an economy of this? I can use this token tomorrow to buy gifts, to do my purchases, to do whatever that I want. Why I'm just bringing this up is the token economy that exists today and that will exist tomorrow. Now, in a simple terms today, if I have some cryptos in my Coinbase, how do I use it at a merchant to be able to redeem it? Can I do it today? No. Are there technologies available to do it today? Yes. MasterCard, Visa, I'm sure sometime our RuPay cards will also do it. I can convert my Coinbase cryptos and get them into a normal, you know, economic, you know, the normal spends that I do. The merchant will still get a fiat currency. But how do you switch between a virtual currency to a fiat currency? How do I make it as seamless as possible? That's very, very crucial, and that will come, is coming. It is no more future. It is no more future. We talked about sports. If I have to use, today, sir, while, you know, we are parents, we tell our kids also to play, go out and play, right? But we know that half the kids today are still playing games on their keyboards. We know it happens. How do I convert those game tokens to something that I would want to do? Something that I can spend somewhere else, right? That's the virtual world and the real world, how seamlessly they can be connected is going to be crucial tomorrow. And this is what the new internet will be. I have the old times of my going to a website, just the information that I can see, it was called as Web 1.0. You know, it was just about seeing information and getting information. Today we are in the world of Web 2.0, which is interactive in nature, which is of course the likes of Instas and Facebooks and you know, LinkedIns and all of them that we have, which is quite interactive in nature. But your data really sits with those servers. They have the monopoly of it, right? The Web 3 is what Deepak talked about Dow. What the autonomous organizations that will exist. But it's much more than that. The most important thing is how do you own the data? So data today sits with your Amazon, sits with your Facebook, shares, of course there are things in which you can share, but how do I really own my data and share it only with the people that I want? We all know how many messages that comes on our mobile phones that are more spam. You know, at every retail store you go to, they will ask your mobile number. Sir, can we know your mobile number? Really not required. Why do we give our mobile numbers there? But that mobile number is something that is used to send 10 other messages to you, or for that matter, our Gmail IDs. Yeah, your mail IDs. That's how you will have to avoid it tomorrow. How do I ensure my data is private to me? Plus, you think your Google data, Facebook data is not being shared, used, sold. It is being used, it is being sold and shared. how do you ensure that nobody touches your data, right? There's a concept that Deepak touched upon was self-sovereign identity. That is one of the key things that you need to, which is there on Web 3.0, which will ensure that you own your data. Does any of you have used DigiYatra? You know DigiYatra is SSI based? It is self-sovereign identity that is implied. So, as far as we can embed technology in these areas, that's how your privacy will start beginning to come in. Now, one part is owning the data. Second part is the virtual economy that is coming tomorrow, right? The whole virtual economy that you will see in multiple platforms, and I'm not saying the word metaverse yet, but there will be platforms that will have a complete different set of virtual economy. Now, metaverse is also a misnomer. Please don't associate with the Meta and Facebook, etc. It's also not just blockchain. There is a lot of other parameters to it. It is your, actually two significant parameters. One, it's your experience. So, bad example, but I'll still go ahead and give. You go into a branch. You used to go to your bank branch so often. Now you don't because you have net banking. I want it as simple as possible. Now I say, I want it as simple as possible, but I still want to feel the experience. So can I go to a Meta branch and do it? Today you have a customer care that you are, that you are interacting with. I don't get the feeling of it, right? Can I have a simulated customer care that sits in front of me and is talking to me? So those are those augmented reality, virtual reality concepts that will exist, that already exist. The simple example that I generally give on Metaverse and the others is the iPhone that came in 2007. Right? At that time also we had all kinds of technologies. We had operating system, we had mobile phones, the old mobile phones that worked on WAP. We had camera separately, all of that. But iPhone at that point in time was instrumental in getting all of these technologies together. That's exactly what Metaverse will do. It'll get all of these technologies that we're talking about together to give you a different experience. So, if we have to survive in this new, it is necessary that we are embracing different concepts of this. Blockchain is one part of it. It is necessary that we start embracing that. It is also necessary that we have a currency that is token-based, which can go and jump seamlessly between virtual and real. One of the reasons also why the rest of the world and India is talking about CBDCs. And, most importantly, we are talking about decentralization, which is the DAO concept also that we talked about. From an infrastructure perspective, the decentralization has a very different concept. But, I won't get on the infra side of how the internet itself will be decentralized. It's a very different concept from a technical concept from infra perspective. So, I just end there. So this is how Metaverse will look like tomorrow. All we are doing today is also part of some of these technologies that will exist and will get to you tomorrow. I'll take a pause here. I don't know. I think it was a short session. Any questions?
You talked about Metaverse and the gradual shifting of everything that we are doing there. As a supply chain person, I am looking at think whether there is a possibility of having it there. Linking it one of your previous slides wherein you showed that you have all the sub-components of supply chain, purchase order, then shipping and payment and all that. And again, in all of them we look at a screen. So the question is, are we Or is there any system wherein the commercial part, commercialization of metaverse has been done, not necessarily in supply chain, let's say in airport industry or in sports or in, let's say, entertainment, anywhere, where metaverse concept has been used to interact with customers?
So, I don't know if you've heard the news, the UAE government has actually created a metaverse for Ministry of Commerce. And they do the legal agreements, they believe they will be actually be able to sign out there digitally. If you've been to one of the, I don't remember which forums, but NPCI is actually working on a meta platform for us in India. We have a metaverse platform that is there up there. So, you know, we know how it works for India, right? It'll get you the stack and they leave it to us to innovate. It'll be the same thing. The platform is coming. It'll be on us. How do we innovate and work on it?
So on that platform, you intend to put some of the systems with which Indians interact and in a virtual platform.
Yes. There are different ways of looking at it. And since it's new, you know, neither me or anybody cannot say how it will turn out to be. But the one way to look at it is, if I buy a Nike shoe, will I buy it on the metaverse digital or will I buy it physical? I can still buy a digital. Will procurement help us do that? I don't know. So I can still, that's one way of looking at it. Second way of looking at is the money that I have in the virtual world, the crypto that I talked about, but crypto is actually a bad example. Even no matter what token, I mean a utility token or a game token or a token that I've got by, let's say you gave me some tokens when I've just done this event. Can I use this token to buy a Nike shoe, which gets embedded into your procurement chain? You have to be able to accept this token for me. You know, so the world is going to go in that direction. We just need to find ways in being able to adapt to that and have a technology up to date to be able to help us in that future. I think the lady wanted. Yeah.
Hi ma'am, I'm Anushri from Metaverse Blockchain Solutions. And this is about, you spoke about a lot of emerging technologies, and I believe in order to surface up these technologies, there has to be research, development and adoption. I would want to know from the blockchain perspective, where are we in this space, in this ecosystem? Secondly, what are the risks of implementation of smart contracts from the perspective of market risks, compliances and sanctions? Are they open to businesses? And thirdly, since you're from the financial market, I've consulted a lot of banks across the globe. It's very monopolistic. We believe in the banks, we trust them, and we don't know about blockchain. It's still under discovery. It's trustless, as you said. How do you feel that we will like to transact, forget crypto, forget wallets, decentralized finance? We want to have an entity which is equivalent to that of a bank, and we want to have transaction on it. Which blockchains we would want to operate upon? So these are the primary three questions which are occurring in my mind.
These are all three related to blockchain, if I understand.
Yeah, we could speak only on blockchain.
Okay. So number one is what types of blockchain, right? And I won't give yes or no kind of an answer, but I'll tell you what is happening more often. More often in the banking side of it, you know, since I'm on the banking side, I have seen that private blockchains are more often used, not the public blockchains. The example, one of the examples that I can give you is in Australia we have 5 big banks that have come together to ease your bank guarantee process. That's a private blockchain. Similarly, across the world that I'm seeing, these are private blockchains. Now that private blockchains, what blockchain beneath it, whether it's going to be Hyperledger Fabric, whether it's going to be Ethereum, whether it's going to be something else, is left to the organization that is deciding it. Was your question between private, public, or it had a different angle to it? What type of blockchains? Is that what you said?
Maybe, and what kind of research projects, since you are from a company called IBM, have you done any such research projects, be it for government, banks, financial technology firms?
There are lots of research. You mean research projects in the banking sector?
Yes.
Yeah, so they're not just research. Actually, there are live projects. There are many, many live projects in production that are already there. My view, a lot of research is done. Research projects are more on the financial market side. So if I want to make my treasury and securities on blockchain, those are some research papers that I can share with you. Is that what you were looking for?
Surely, I look forward. And when you spoke about risk, I mean, is there any risk of implementation of smart contracts, be it supply chain or different industries, or for government?
Many risk. Yes,
Can you name a few
absolutely.
and we need to be cautioned about it?
Yeah, so one risk that I would look at is the volatility risk itself. So, if you are using crypto, then you will have the volatility risk for sure. We're also talking about credit risk here, because in the credit risk in the financial market, I would not while I would know at a point in time, I'm just trying to get back to your question. So, for example, your Nirav Modi case, for example, right? So the Nirav Modi case was because you were having a rolling credit from one bank to the other. The problem that it might solve, if you have a view to all the bank guarantees that were across, is that you would know that there was a rolling credit that kept moving around in each one of them. That problem would have solved. But what would you not know, however, is that how many such are happening in US or for that matter in any other country. So that's the credit risk still exists. Or I'm talking nonsense.
No, I understand that. In fact, I'll give you another use case I've been researching upon. We are all addicted to this Zomato, right? And there are a lot of merchants listed there. There is a payment cycle which the merchant is dependent on Zomato. Though the product and the service, everything is delivered by the merchant. But Zomato has its own settlement cycle, right? And the merchant is dependent on that settlement cycle to clear the funds, right? What if there could be a blockchain-based platform where the ledger is mutually shared, the transactions are mutually shared, and the remittance happens instantly? Why a merchant has to wait T plus 30 days for his own money, for the service which is already been consumed by the customer, and he's delivered to the mark?
Yeah, so that's a very classic example and a valid example for what you mentioned.
Same occurs for Ola and Uber. The drivers have to wait for the credit through their wallet. Now, Ola has actually stopped consumers from paying directly to a customer. They either pay digitally or through the wallet only to the Ola as an organization, which I feel is very monopolistic.
Yeah.
Amazon, I booked a phone the last month wholly, and I paid 15,000. I did not use the phone. I did a return order. The refund came to me T plus 7 days. Why is it so? Because they're Amazon.
Yeah, that's correct.
So why are you not, as an organization, delving into these kind of organizations where you are big, you're a big brand? Why don't you approach these kind of use cases and build in blockchain as a solution?
Actually, there are. The ones that you talked about,
These are cases which are still prevalent. I'm a live user.
Yeah.
Consuming all of this.
So there are, what you just talked about. So for example, we have all the big retail brands, for example, together on a blockchain network today, which is called as a food trust. Right? We have them on the network. Of course, this is very US based. It's not in India that we've done it. That exists. The second example from a financial market side, if you look at it, the whole clearing and settlement of CLS, the CLS net for the FX is on blockchain. The DTCC, the Data Trust Clearing Corporation that we're talking about, that trade warehouse is on blockchain, so that at any point in time anybody can see where the trade exists. So there are many, many examples. I think, sorry, what's your name? Yeah, what's your name, sorry?
My name is Anushri. I'm from Metaverse Blockchain. We're a New York-based firm. Yeah.
Okay, so Anushri, I will have a separate conversation with you, I think, outside. And I don't know if you were there yesterday or in Deepak's session. There are some of these things that are covered. Yeah, thank you. Yeah.
from a non-banking finance company. I just want you to delve a little more. You mentioned of an Australian example where they tried to create smart contracts from normal legal agreements. And you said they were 5 years too early. What has changed now and how has it become better to implement that?
Yeah, first of all, the technology itself has changed. You know, the talks about privacy that we talked about, like ZKP and others, didn't exist 5 years earlier, right? So a large part of that technology evolution has happened, number one. The second is the regulations. The big reason in these cases are the regulations of the country that is different. So 5 years back then, they could not get to fly it and, you know, it just died its own death. But that Australian example that I'm giving you, they actually made those bank guarantees, which are smart contract based, legal. So they worked with the legal entities and the governments to ensure that they actually get legal. So a big part of all of this is, especially from a legal perspective, if you're doing it, the country's regulation, the country's acceptance plus understanding of that technology and the impacts of it is very, very crucial. I think that's a big piece that has changed. You know, it was an amazing concept. I know the lady that I was working, her name was Natasha Blaicha, very smart lady, but she was 5 years ahead of what she was trying to do.
I would love to speak with you offline.
So, thank you. Thank you. And thank you for hearing me out. If I made a mistake, please bear with me. We can talk separately.
Thank you, ma'am. Requesting Dr. Thank you so much, ma'am. Moving on to the next lecture. It will be given by Professor Sandeep Shukla. Professor Sandeep Shukla is currently Poonam and Prabhu Goyal Chair Professor and ex-head of the Computer Science Department, IIT Kanpur. He's on the Board of Directors of Reserve Bank Information Technology Private Limited and also member of the High-Powered Committee on Cyber Security or SEBI. He's a PhD in computer science from the University of Albany. He has worked on formal methods for system design and other problems related to embedded system design as a postdoctoral research associate at the University of California. So requesting him to please kindly come and deliver the lecture.
Good afternoon. Can you hear me? So good afternoon, everybody. So I'm standing between this and your lunch. So I'm going to try to finish things as quickly as possible. So I'm going to talk about potentials of smart contracts in digital India. And the entire idea comes from the National Blockchain Project. It's a project that we have been doing since 2018 under the funding of the National Cybersecurity Coordinator's Office. And the idea was to actually demonstrate some e-governance applications of blockchain technology. And in that process, we developed solutions that went live in Karnataka, and also certain projects that are used in multiple different academic institutions. So I'll talk about that. But before I go into the actual smart contract applications or blockchain applications, I want to say a few things about smart contracts. It's kind of summarizing what you have heard in the last 2 days. So what are smart contracts, right? So yesterday you heard that, and today also from Deepak's presentation, that smart contract is kind of an evolving concept. It's not fully defined yet. But in general, what we understand is that smart contract is a program that is self-executing, and it's basically or tries to automate certain actions that you would have normally taken in case of abiding by some legal agreements. So for example, if you take a loan and against a collateral, and you have a legal agreement that if you don't pay in certain time, or if your loan amount is above certain fraction of your collateral, then your collateral may be liquidated by the lender, and in case you pay back, then your collateral will be released. So this is the kind of legal agreement that you can put in a program, and then you can basically send the collateral to the contract, and the contract will accordingly pay out the loan to your account. And in case you want to pay back, and then the collateral goes back to you, these kind of things can be easily automated with a smart contract. So smart contract is a self-executing program, and now you might ask that most applications that we do today, for example, we use various kinds of like UPI, for example, GPay, or we do various other kinds of things like buying stuff from Amazon and returning stuff on the website and so on. All these things are actually programs, right? So you are accessing those programs either through an Android application or a web application. And in the back end, as you click on buttons or touch certain events, buttons, then you actually, in the back end, at some server somewhere, some execution happens, right? And that execution changes the state of the program. It changes entries in the database, or exposes certain entries from the database to you, and so on. So why are they not smart contracts, right? So why most of the automation we have been seeing in the last 10 years or so, including, for example, Aadhaar, right? So Aadhaar e-verification or things like that. Why are they not smart contracts? Why is it that, what is so special today about smart contracts? So one of the things that is important in the smart contract is that once the smart contract execution is completed, the transactions has to be trackable and irreversible, right? So this is something that distinguishes smart contracts from regular web applications or Android applications and so on, right? So, so let's see, how do you make the program self-executable, right? So, so you need an execution platform. So, for example, in case of a web application, you have a server sitting somewhere, either on the cloud or on a regular server. And in case of a smart contract, we usually do this on a virtual machine. And there has to be an event handling interface, right? So there has to be a way to actually, trigger the executions through some kind of events. It could be a touch of a button, or it could be making a transaction, things like that. And so there has to be a way for the program to actually wait for events to happen or transactions to come to it, to its interface, and then appropriate functions have to be called. So yesterday, if you were there, you have seen some example on Solidity in the last presentation, where you saw how using Remix the speaker was actually interacting with the smart contract. So he was putting in inputs, either inputs to the smart contract, or he was pressing a button, and certain events were generated, which would actually invoke certain functions that are already written in the smart contract. And then, as Deepak has already discussed in detail, that the execution has to be deterministic. Now, why is the execution needed to be deterministic? Is because smart contract has certain properties which, even though we have not fully defined what smart contracts are as a final definition, since 1996 we have the notion of smart contract, but we haven't fully defined what smart contracts are, but we all have more or less a consensus view of what smart contracts are. So the smart contracts, whatever state change you make by a transaction has to be irreversible, and the state change history must be immutable. So you cannot go back and say that this event didn't happen, or this transaction didn't happen, or this transaction happened in a different way. And the state trajectory has to be trackable, and the information about the state has to be highly available, and so that even if the program crashes, it should be not invisible to the stakeholders. And the information has to be transparent, and state change should be verifiable by anyone, right? So this is what a smart contract requires, and that's why the regular web applications or Android applications that we see today are not called smart contracts. They are regular programs. So smart contracts execution ecosystem, some executions may require authentication, right? So you may have to be a certain person, a certain account holder to execute certain transactions, right? So in many times you do not want any random person to actually execute that particular transaction, because it involves movement of tokens or movement of funds, etc. The execution must be deterministic. We have already discussed that. And state must be replicated for high availability. So it has to be replicated. And the public part of the state. So not every information in a smart contract need to be publicly visible, but the important part of the information that depends on the contract and how the contract was designed should be transparently visible. And as I said, the history of the state change must be immutable, and state changes must be verifiable by anyone, right? Now, all that stuff together tells you that I need some kind of an environment in which this smart contracts can execute, and distributed ledger technology or blockchain technology is good, fit for this kind of an execution ecosystem, right? So it's the smart contracts, the idea of smart contracts by itself cannot really exist without having a execution environment in which these properties, that smart contracts are supposed to have can be actually enforced. And this is why smart contracts are usually seen on blockchains or DLTs. So blockchain is usually the smart contract execution environment. So for example, you can the first blockchain that we have seen is the Bitcoin blockchain, right? So in the Bitcoin blockchain, for example, when you actually do transactions, right? So you have multi-sig transactions, right? So where multiple signatures have to be present for that transaction to be valid. Similarly, you have micro payments mechanisms in Bitcoin. So those are also smart contracts, but those are very, very not so parameterized smart contracts. Those are smart contracts that are very, very hardwired into the Bitcoin blockchain ecosystem. So the smart contract that we first saw with the full programmability was in Ethereum, right? So Solidity based smart contracts that came in Ethereum that gave you the ability to for users to program various kinds of logics. So multisig or micropayments in Bitcoin were not possible to actually do anything, any variations of that by the users. So by having, although the Bitcoin blockchain has a scripting language, and that scripting language is very, very, it's quite limited in what it can do. Its expressibility is quite limited. Therefore, you couldn't do a whole lot of things with the Bitcoin blockchain scripting language. Whereas in Ethereum, you have the full, what we call Turing complete language. The Solidity is a Turing complete language. And then since then, all the other blockchains that have come up have the ability of, executing programs. And this execution of programs, these programs are written in various other languages such as Golang, and even in, you can now write programs, the smart contracts in Java and JavaScript and various other languages. So blockchain provides an ability to actually replicate the execution across multiple nodes. So not only one node is executing the smart contract, but every other node which wants to create a block or what we call validating nodes will actually also execute the program. And that's where the determinism helps, right? Because if the program was non-deterministic, then in one node, it will execute and produce one result. In another node, it will produce a different result. And therefore, the other node will not be able to validate the transactions that was done by one node or the node that is creating the block. And the state change is a transaction, and these transactions are recorded in the blocks. And state change history, therefore, becomes immutable because in the blockchain, the transactions in the blocks, once the block has been made and a sufficient number of blocks have been built, the blocks you cannot go back and change the transactions unless you have an immense amount of resources, either computing power or resources in terms of stakes and so on. So any validating node can also execute the program to verify the state change, and the replication of execution provides availability, and anyone with the access to the blocks can track the entire state trajectory, right? So the requirements that I was talking about earlier, blockchain provides that execution environment which allows the smart contracts to have these properties that we want. So as Deepak was earlier saying that oftentimes he says to a person who wants to do a blockchain project, we often hear this from many organizations that we want to do something with a blockchain. And then we ask, like, what is your problem? First tell us the problem, and then we would analyze it, and we'll tell you whether a blockchain, smart contract, etc. are required or not, right? So in many cases, a blockchain may not be required. So, so in many applications, and web application or some kind of a application based on server or server running on a cloud is sufficient, right? So it depends on what your assumptions are about your trust model, what your assumptions are about visibility, transparency, and then what are your performance requirements and many other things, right? So but in general, given that we have this digital, there is a whole digitalization of services in India for the last 10 years or so. We have Aadhaar, we have UPI, we have Digi Yatra, we have various other, DigiLocker, various kinds of applications. So the question is, which of these could have used blockchain for various properties that we want out of them? For example, if you look at Aadhaar verification, right? So when we actually go to a bank or some place where we have to do an Aadhaar-based authentication, we give fingerprint or we get an OTP, and based on that, everything happens through multiple different servers. Like for example, there is a concept of AUA, and there are at least two different servers through which this request goes all the way to the Aadhaar data center, where your fingerprint is actually matched or your OTP is matched, and then the corresponding success or failure comes back all the way through these two different intermediaries back to the final bank or wherever you are doing your e-verification, right? Now that is a lot of multiple different steps that it has to go through. That's one thing. But the second problem is that if there was a case where a mobile company, I think it was Airtel, which was actually asking for Aadhaar authentication at the time of taking your SIM card. And at the same time, what they did was they reran the same authentication and created a bank account, Airtel, some kind of an Airtel bank account. And then since that bank account got connected to Aadhaar, the gas cylinder subsidy of people were being deposited to that bank account, right? So now you do not know how many times people run your e-authentication. In Aadhaar, there is also a demographic lookup that you can do without fingerprint or without the OTP. So how many times organizations are doing demographic lookup of your Aadhaar data? This kind of information initially was totally unavailable, and after some time UIDAI, they actually created a web site, so you can actually log into the UIDAI website and see all that information, right? So this is a completely web-based information. So there is the question of transparency. Are people using my Aadhaar information or looking up my Aadhaar information? I have a right to know because it's my information, and how I can know that information. So UIDAI authority made it available through a web application, that if I authenticate myself to them, they will tell me in the last so many months who looked up my Aadhaar information. But the question is that what if they actually omitted some of the lookups, right? It's maybe they're doing, somebody is doing surveillance on me, and somebody looked up that information, and I am not being shown that. So there is this notion of trust. Do I trust the servers or the programs that are showing me all this data over the web application? So a blockchain solution, a smart contract based solution would actually make this thing much more transparent, right? And the public trust on the system would actually will be enhanced, because now I know that this is immutable. Nobody can hide some of these transactions. The transactions that were done on my personal information was done. Nobody can actually hide that information because it is put in an immutable state through the blockchain technology, right? So this is the kind of places where the question that the application developer should ask is, what is the trust requirements, right? If I feel that everybody trusts me and there is a public trust in the government service or the service of a particular company, then they can actually run put that system on the web application or a server, and there is no need for a blockchain. But if there is a belief, there is a reason to believe that there would be doubts, then it is better to come out and create a transparent system. So transparency and trustless system design is one reason why you would want to go into a smart contract and blockchain environment rather than a server-based environment. The other issue is that when we do UPI, for example, so in the UPI, whenever you actually initiate a payment on UPI, first the virtual address, your virtual address has to be translated, and there would be a bank through which this virtual address was created. So it first goes to that bank. Then it goes to your the account. The account is maybe in another bank. Then it has to go to the again the UPI servers, and then it has to go through the receiving bank. And so there are multiple different intermediaries interposed in one transaction of UPI. So even if you are making a 50 rupees transaction, it goes through at least, I think, about four different intermediaries. Now, this is what we call friction in a payment system. So there is a friction in the payment system, and if one of these intermediaries fail to function, then the entire process will fail. So if we want to reduce friction, for example, then also if this entire thing was based on smart contracts and blockchain environment, this friction can be reduced. So in many cases, we do this for trust. In some cases, we do it to have transparency. In some cases, we do this for frictionless delivery of service. And in some cases, we do this for trustless, create a trustless interaction, right? For example, in procurement system, for example, so we have multiple different parties involved, and these multiple different parties keep all their data in silos. And every time that we want to have a full visibility of the status of what is happening, then in that case, we have to basically go across these different silos. And that is difficult because of these organizations have no reason to trust each other. So therefore, they do not necessarily will give access to APIs to each other's servers, so that all that information can be actually fetched from all these different servers that are owned by different organizations. So they have to come together into some kind of an enterprise agreement between these organizations, and then create a way to actually share this information that is relevant to all the parties. And that is where this blockchain technology will be useful. So therefore, so web applications has sufficed so far in the Indian digitalization journey. We have had very good, successful, actually, Indian payment system is probably one of the best in the world in a digital payment system. Even now Singapore, I believe France, they are actually wanting the UPI technology. We have done well with our ID system, although it's a centralized ID system, but it is also one of the major ID systems in the world. We have done DigiLocker, we have done various other types of digitalization. The question lingers is that whether you want better way of information sharing with much real-time access to information across various silos, whether we want transparency across multiple silos as well as transparency to the citizens, if we want more trustworthiness with respect to the various services we provide through digitalization, and all that stuff, if we consider the various services and if we look into these questions, then we'll be seeing whether we need this smart contract and blockchain based solutions, or we can still do with, and now everybody is going to cloud. For example, many of the applications now are being put in cloud. So this kind of answers we have to actually get in order to know where to go. So now switching gear from that, I'm going to say a little bit about the multiple different projects that we have done from our national blockchain project. So I'll talk about, I'll talk a little bit about each of these. One is about the land registry in Karnataka that we have done, and then an advanced e-procurement system that we have done in Karnataka as well, and verifiable credentials via self-sovereign identity. And then right now we are doing one for the Kanpur Development Authority, is a transferable development rights management. So now as you will see that this entire end-to-end business process is not implemented on blockchain. Certain parts of the system is implemented on the blockchain because of this issue of trust and because of this issue of transparency. So these are the Kaveri blockchain project is the name of the land record registry project that we finished in 2021, and it was used in 6 districts. After 6 districts, it was live. The head of the e-governance in Karnataka retired, and since then it is still in 6 districts and not in all 70 districts. There is a blockchain-based e-procurement integration project we have done, which is also for Karnataka e-governance department, which is live right now. The self-sovereign identity project, and we have given degrees at various institutes using the self-sovereign identity mechanism that has been used by multiple different organizations. And then currently we are doing this TDR project, the transferable digital rights, which is being developed right now. So in all of these cases, we are using permission blockchain. Actually, we are doing Hyperledger and the Hyperledger fabric, basically. And the idea is that we have actually in this Kaveri blockchain case, we have 5 different nodes, the consensus nodes, that are actually distributed across multiple different government organizations now you might and blockchain purists will not consider it as a distributed ledger technology, because they will say that this is all, the government departments, so they can collude with each other and actually change the entire ledger. But here the trust is relative concept, right? So the reason why the head of the e-governance actually approached this problem with blockchain is because there has been multiple cases in the courts in Karnataka where land records of multiple different people had different owners than the original owner, which was done apparently in the back-end server. The server was maintained in the land registry office, and apparently things were changed. So he wanted something to be actually more immutable. So having put this in multiple different government departments, it was assumed that there is not enough collusion across these various departments to actually do this. Now you can actually, depending on your assumption of trust, you may have to distribute it to a much bigger set of organizations than just 5 of these organizations. But the idea was that not everything was, like for example, the actual deeds were not put in the blockchain, but the proof of transactions that you are doing on the transfer of rights or transfer of lands, that information was being put on the blockchain. So this information and the proof of consent, that the user consented, this was done through eKYC, through Aadhaar, and then we actually created a smart card in which the private key of the user was embedded, and the user was given that card, and then through that card they can prove their identity and then also record their consent. So this information was only on the blockchain, not the entire land record or the deeds. So you can see pictures of the first day of actually opening this. So here this person is actually holding a card, that smart card that we have created. It's a Kaveri smart card. And second project that we have done for the Karnataka e-governance department was an e-procurement integration platform. Here also the actual functionality that was put on blockchain is very simple. The idea was that different states have their own different e-procurement systems. And various vendors and suppliers, they appear as different entities in the different states. So therefore, if a particular entity has a certain issues with for delivering things on a particular state, the state of Karnataka wouldn't know, and then accordingly they would actually award this maybe the tender to that particular organization, and that could create problems. So therefore, this was actually an information silo, integration of silos, data silos across multiple different states. And this was again done on a permission blockchain. Again, it was done with the Hyperledger Fabric. And it was actually working as a national deduplicated supplier data store with award of contract and work experience certificates linked to supplier identity. So this was, this onboarded Telangana, Andhra Pradesh, Chhattisgarh and Assam e-procurement systems, and various banks were also onboarded into the network. So that was the e-procurement case. The next one is the transferable development rights project that we are currently doing. So here the idea is that if the town for planning purposes or the city for planning purposes procure your land, then instead of paying money, they can give you development rights, and initially that was being given as some kind of a physical certificate, and then you can actually transfer that development right to somebody else and get money. You can also fractionalize the development right and give to multiple people. So this project is being done by implementing a token system. This is being done on Quorum blockchain system, and this is actually by creating a tokenization of the development right. And this token, through the smart contract, we can actually fractionalize the ownership of the token, and this is currently undergoing. The work is currently undergoing and supposed to finish next month. So this will help create a marketplace for development rights. So you can actually go to the marketplace and sell the development right that you have received from the government. So it is integrated with the building plan approval portal. It has certain other advantages. We have created a wallet, and we have Aadhaar-based identification, and you can trace the ownership rights over time through the immutability of the ledger, and there is a non-repudiable consent through Aadhaar eKYC. So the last thing that we have done, not the last thing, but this is another thing we have done is the creating a self-sovereign identity system using the blockchain technology. So here, the idea is that instead of having a identity in a server somewhere, like in Aadhaar data center, your identity information is all on the Aadhaar data center, and all the information is under the control of this authority, and the user has no, other than the legal provisions that protects the user rights, there is no technological provision for user to actually have sovereignty over his or her own individual data, right? So the authorities can actually use that data any way they want, access or give access to that data any way they want. So that is, as opposed to that, self-sovereign identity is when only the user has the access to the data, and the authority that issues the identity does not keep the data for itself. But there are cryptographic techniques by which the fact that the issuer of the identity, the legal issuer of the identity, has issued that identity can be established by cryptographic digital signature verification. Also, user can actually decide who to share the identity information with and who not to share the identity information with, and also amount of data that they want to share. For example, if I want to prove that I am above 18 or I am above 65, I do not need to give my father's name or my address or my exact date of birth. I have to be able to prove cryptographically using zero-knowledge proof to the verifier that I am above 18 or above 65, whatever I want to establish, without giving out any more data. Right now, if you want to prove your age, you have to show your Aadhaar card or some other document, driving license, where your birth date is, and much more information than just your age will be revealed to the other party, right? So this is what is called selective disclosure. So we can do selective disclosure also with this self-sovereign identity mechanism. So this is what we want to create. So, and this is what is, this is actually a W3C standard called verifiable credentials. So you can actually create verifiable credentials for any kind of identity data. And then you can actually hold this verifiable credential in a digital wallet, and this digital wallet can communicate with another digital wallet to actually provide any kind of information that they want to provide using NFC or Bluetooth or whatever local technology is required. They do not need to go to any server to actually prove their identity or share their identity like we do currently in DigiLocker. So this is the idea. So this is how we have developed this. So we have a permissioned blockchain. This is again actually Hyperledger Fabric, but it is publicly accessible in the sense that there is read access by the public, but not write access. Write access is only given to certain organizations which issue identity. So let's say you are an issuer, and so let's say you are the PAN card authority. So what you would do is that your identity has a schema, right? So you have a schema of the identity, so you actually registered the schema, because anybody who wants to interpret the data that is being shared as your PAN card information needs to know the schema of the PAN card. And then you also registered the public key of the issuer on the blockchain. So the blockchain here is actually being used as an information sharing conduit or information sharing platform that allows everybody to register their public key and make sure that this public key is not tampered with. So that's the immutability property of the blockchain is being used. And now the issuer will now create the credential, let's say in this case PAN card, and the holder can actually request the issuer about for issuing the credential, and the issuer will issue the credential to the holder's wallet. Now let's say the holder needs to go to a verifier. The verifier, let's say, wants to verify his PAN card. So verifier has to now, once he obtains the data from the in the verifiable credential DID, what we call data identity definition schema. So then verifier will actually look at the issuer and go to this blockchain and check the schema and the public key of the issuer. And once he has the public key of the issuer and the schema, he can interpret the data and also check the signature on the information. If the signature checks out, then this is not only issued by the issuer, claimed issuer, but also data has not been tampered with, right? So the tampering data has since the issue of the document, no tampering has happened. Now, this kind of thing actually can also happen in something like DigiLocker, right? So in the DigiLocker, what happens is that you go and you go to the server, and the server redirects you to the issuer, and the issuer has the PDF of the document, and the document is digitally signed. So you can still check the digital signature of the document and make sure that this is actually valid and the PDF has not been tampered with. The difference is that in this case, the data still resides at the issuer, and the issuer, basically the holder of the degree or the credential actually instructs or consents for that data to be shared to a verifier. And the verifier receives the entire document, and the verifier, so there is no selective disclosure. The user, the holder of the credential will not be able to decide which part of the information he wants to share with the verifier. And there is no zero knowledge proof, so certain information such as age and other things, or the location, district-wise location, etc., cannot be proved without giving out the entire information about the user. So here is a sample journey of this kind of a self-sovereign identity. So let's say there is this girl called Vidya, and she has the digital wallet. So this digital wallet you can get actually from the Google Play Store or from the Apple App Store. It's called Indici wallet. So this wallet you can get, and then you can go to the other authority. Now other authority has not implemented it yet, so you cannot get it from other authority right now. But we are trying to convince them. So you apply for your Aadhaar. So at this point you will do a eKYC. So we are bootstrapping of Aadhaar. In the absence of something like an Aadhaar in a country, we have to do something different. We have to get from the driving license authority, or somebody has to be onboarded to this system. But since India has already Aadhaar, so you can actually get this from Aadhaar, and Aadhaar authority sends the verifiable credential to Vidya's wallet. And then Vidya goes to IIT Kanpur. So she's a student of IIT Kanpur, just graduated. So she goes to IIT Kanpur and apply for a degree. So now IIT Kanpur has to first figure out if Vidya was a student there and graduated. And also they have to decide whether it is indeed Vidya who is asking for it. So they will use the Aadhaar the Aadhaar credentials. They don't have to do an additional eKYC. They can use Vidya's Aadhaar credential and can verify that it is Vidya. And the rest of the verification they have to do from their data. And they can actually give a degree to her wallet. And then she goes and applies for a job. So here, let's say she goes to a company, and the company wants to first establish that it is she is indeed a bona fide person, and also that she has a degree, a requisite degree. So then right now she has two credentials in her wallet. So she shares those two credentials to the job portal, and prove her identity and degree, and receive and in case she gets a job, she gets a job certificate, which is also given in terms of a verifiable credential on her wallet. And then finally she applies for let's say goes to the bank to apply for a credit card. So then she has to prove identity, address, and income. Now the income is already embedded in the job certificate. So now the bank can verify it instantly. So this will make things instantaneous, right? So the first identity establishment of her wallet is the key, right? So it can be done through Aadhaar, or it can be done through in-person verification. Like right now, the way the degrees are given through IIT Kanpur right now, we don't have the Aadhaar credential yet. So we do this through the Dean of Students office, through the in-person verification. So so far the various universities have given degrees on our system. For example, IIT Kanpur has done 2 convocations. Indira Gandhi Open University has done once. The UP Technology University, AKTU, they have done once. The NIT Rourkela has done twice. IIT Indore has done once. And then currently also the National Skill Development Corporation, they are planning to give their training certificates through this mechanism. So the various things that are involved in developing this ecosystem, you need a digital wallet or some kind of a application uh, where the actual credentials will be stored, cryptographically encrypted, and so on. It has a selective disclosure feature. You can selectively disclose certain information because each piece of information in the DID are actually digitally signed. So it's not like an entire document is digitally signed, but every piece of information is digitally separately signed. Proofs cannot be transferred. So if you prove your identity, it cannot be transferred. So right now, if you give PDF to somebody, they can send it to somebody else by making some surgery on the PDF, etc. This is not possible here because of the digital signatures. Zero knowledge proof can actually be used for proving certain predicates about your identity. It has multi-credential proofs, so you can actually use parts of various credentials to create a proof. Interoperability and secure and private channels to send the information from holder to verifier. And it has also a few other things that are enabled through this. For example, auto-filling of web forms using your verifiable credential information with your consent, passwordless login, various other activities can be supported through this. So I think that's all I have. So what? Let me summarize this. So in the National Blockchain Project, we have been trying to show by actually going to the real government departments and real government business cases that certain aspects of your certain digitalized services can be actually made better, more transparent, more trustworthy, and more information, the frictionless, by using the blockchain technology. And so we have picked up, well, we didn't pick up necessarily on our own, but certain opportunities came to us, like the land registry came to us from the Karnataka government, and through that the procurement issue came in. But overall, our experience is that since India is going, at a very rapid rate to providing digitalized services to citizens in many different aspects of government services, it is, and there are issues with respect to friction, with respect to too many intermediaries involved, with respect to various kinds of trust issues or transparency issues. So there are various ways that certain aspects, not necessarily the entire end-to-end business process, can be put into a blockchain-based solution, but certain aspects, selected aspects of the problem can be actually solved using blockchain and provide these properties of transparency, trust, low friction, and the reducing the intermediation. So I'll stop here and take questions if there are any. Yes.
Good afternoon, sir. It is nice to hear you here. I want to ask a question about Hyperledger Fabric and land registry.
Mm-hmm.
If you are going through the IoT devices for geolocation-based land registry, then can we remove the third person available at the land, or who is going to measure the land at that time? Or
no, so we are not actually solving the land record issues. We are only keeping the information that at this point, so and so, who has been proven to be so and so, has given consent to do this transaction. So we are not solving the land record problem. In fact, when we talk to the the various land revenue departments, land record problem is a different problem. It's a much more complex problem. There are a lot of disputes and a lot of different issues, right? So we are not actually putting land records on the blockchain. We are just putting who did what and when in terms of transferring rights to land at various points in time, so that no unwanted or unwarranted changes to the deed or to the land registry data can be made.
Sir, one other question is that can we program a hardware device to be smart contract specific so that device can send the data to the blockchain based on smart contract? Like vice versa, like some device can work on based on smart contract too.
No, so IoT devices, so IBM had this multiple different nice stories about this washing machine fitted with IoT devices, which tells which knows when the soap has decreased to a level where it has to be ordered to a marketplace and all that stuff. So all those, I don't know if those were implemented, but at least those kind of use cases have been discussed. Smart, this smart home kind of use cases.
I heard
So
about
I think
Tesla, sir. Tesla will, if required any part, they can order that directly to the market. Like
right.
that. Yes,
Right. So the question is, in India, we are not ready to be that level of automation, right?
Yes,
So my mother still wants to do her own shopping, right? Yes. She doesn't even trust a big basket or something. So at this point, I don't think our washing machine will order soap or something, right away over blockchain. But the idea is that it will reduce the friction in the entire automation process, right? So it will break down the silos, data silos, and actually make a very transparent, movement of data flow, right?
Thank you, sir.
Hello, sir.
Yes.
Good morning, Shukla sir. First of all, I would like to thank all the three eminent speakers for wonderful sessions today, especially Dr. Deepak sir for a wonderful interactive section today. So I am Satyapal from CAG of India. So my question is that whenever we automate our existing manual systems into an automated system by introducing business process re-engineering, by developing an IT system, we do involve third-party auditors. Like you said in case of Karnataka State Data Center, this STPI and IIT Kanpur, they were involved. And Deepak sir also said about that. But they are like the QA QC, isn't it? But what about the provision for IT audit by external auditors like CAG of India? So I mean to say, like inbuilt provisions for audit trail and audit module. Like for example, we have been using e-file system through e-office, and it has provision for audit module. And we have been asked more than 2 years ago what are our requirements for this audit module, but it has not been implemented yet. So my question is that. Thank you.
Okay, so Deepak, you know the answer to that?
In between, right? So you put the audit node. Right now what we have seen and we have heard is the stakeholders are actually the real players and it's the validators who do it. But you can then have a certifying node or an audit node also being a part of it. Now, when I do my payables for the government employees, I can have the payroll department now, the account payable department also be a part of that node, and then they do it. At that time, they can refer the provenance, like what we have said, to use it and then implement it. While doing that, they can get the audit report or the audit, the immutable audit you get from the blockchain to do it. So depending on what your use cases or what your requirements are, the easiest stuff is to add another node, which is an audit node or a certified node, or have someone who is sitting outside but looks at all these audits and audit logs, and then come back and say this is okay in the workflow to put the final tapa, if that answers. So you can do it proactively if you make it audit.
Thank you, sir.
Okay, I hope you got the answer. Thank you, Deepak.
Sir, one general this one. This DO is actually that sir has taken a very nice, interesting class in the morning. That Deepak sir. So that DOAs, DAOs and these smart contracts, are these both similar or there's some difference?
So DAO is a decentralized autonomous organization which is implemented using smart contracts, right? So a smart contract by itself doesn't create a DAO. DAO has to have certain smart contracts which has governance of the organization and business processes of the organization all inbuilt. So it would be probably a bunch of smart contracts that are put together to create a DAO.
Sir, actually why I asked this one, he shared one incident. So wherein one of the DAO, there was some problem and somebody has taken some 10 million or so. And then after that, I think the creator of that DAO, he actually decided to go back to 20 steps and then actually see it as okay, the next 20 steps didn't even occur.
Right.
So now actually in US labs, we have seen that this is irreversible and immutable. And history, you cannot actually erase the history.
Right.
So then...
no, so that's why they had to create a fork, right? So let's say I have blocks up to this point, right? And this is irreversible, right? But I can create from an earlier block, I can start building another set of blocks, right? And that set of blocks will actually be my version of the blockchain, right? So this original version of the blockchain will go in its own way, and that will have its own dynamics. And I will create from earlier, before this incident happened, I can create. Now, to create such a fork, you need immense amount of power, So in this case, in the DAO case, a large majority of the developers of Ethereum, they decided to do the fork, and miners who were actually involved, the majority of the miners agreed to build from a previous block, and not to follow after the block where this stealing happened. So therefore, they could do it. Now, not anybody can do it because the consensus power in the blockchain has to be enough, right? So the consensus power right now we have a proof of stake, right? So there has to be enough consensus power to actually branch out from this thing. So a lot of people have to agree, right?
Because it is affecting to all the stakeholders, so everybody would agree except the hacker.
Right.
So I think then
right.
It can. Thank you, sir.
Okay, thank you.
Now presenting the memento to Professor Sandeep Shukla. Thank you so much, sir. So we are concluding our today's session of the conference. I hope you all had a great time. I would like to thank all the eminent speakers, participants, director, faculty, and the entire managing team of HANIFM. We look forward to more such events in the future. I would also like to thank the scope organizers for their assistance in organizing the event. Thank you and have a good day.
So we'll have lunch now. So lunch is there at same place that we had yesterday.